Reminding you of what we learned yesterday, because I do believe that there was some confusion. So I'm just going to pick some graphs, just some random graphs, and we're going to just talk about it, okay? So just follow along. And I want to start out by talking about the extrema, okay? Would you say that that was kind of one of, like, the minimum, maximum stuff? Is that min and max? Is that part of it? Okay. So I want to pick a couple graphs and just talk about what we talked about yesterday, because it's part of today's assignment too. So just looking, you don't have to write anything down, just pay attention. So I just found a page that had some graphs on it. So guys, look, this is a line. There is no min or max, there's no relative min or max. All the points are equally, there's not one point that stands out higher than the other or lower than the other, okay? So with a line, there's no extrema, you don't have any, okay? Let's look at this graph. This graph has some local, or wait, what do we call it? Relative in this class, sorry. Every book calls it something different. Relative min and relative max. So what this means is, actually, let me talk about the other one first. Look at this graph. This one has a minimum, just a plain old minimum, because it has a point that's lower than all the others, okay? It's at 0 or 50, 0, whatever that point is right there, okay? What's the difference between calling this a minimum and these two relative minimums? Okay, that's the difference. That's the big concept here. The reason these are relative minimums is because there's two of them. Like in our viewing area, we have two minimums. We also have a relative maximum. Why is it relative and not just the only maximum? Because it goes up forever. There are points that are going to go higher than this point, right? That's what these arrows mean. It means keep going. But in our viewing area, that is the highest point that we can name. So if it's relative, just means that there could be points that are higher or lower, but it's usually a turning point, like a curve in the road, okay? So like, look at this one. We have a relative max, a relative minimum, another relative max, and another relative minimum. So we have two relative minimums, two relative maxes. Why are they called relative? Because there are other points that are higher and lower than those. But in the viewing area, it's like, in viewing area, like the little screen we're looking at, like on your TV, you might know that there's more going on in the scene around it, but what do you see in that rectangle on your screen? Okay, so in our little area, we have some points that stand out that are higher and lower than all the others. That's all that means. Does that help a little bit? Like this, what is this one? What would you guys call this one? First of all, would it be categorized as a min or a max? Max, because it's at the top. Would we call it just a max or a relative max? Max. Are there any points? Because we know these are going to keep going. Keep going, or maybe not. But this, in our viewing area, that's the highest point, and it's the highest point. This graph is not going to suddenly turn around and go back up, okay? There's not arrows pointing in the up direction, okay? Just like this one has an arrow going up, so we know there's points higher than these two. There's lots of points higher than those two. But for where we're looking, so think of it almost like as when it's a curve, it's like a turning point. Those are your relatives. That's going to come up again today. And I'm going to tell you, the graphs they give us are not super nice all the time, where it doesn't always cross at a exact cross. So sometimes we had to estimate. Who was really good about that yesterday? Amanda, you were really good about that, rounding. So you'll see in the homework today, I might write 2.1. You might write 2.2. It's okay, all right? It's just an estimate. As long as you know it's in between two numbers, that's really all I'm going to be looking at, okay? Unfortunately. Now, this today, super easy concept, okay? Really, really, really easy concept. It's end behavior. You can talk about end behavior a couple different ways. Today, we're only looking at end behavior on a graph. Looking at a picture, you're going to tell me about the end behavior, which I'll explain in a second, okay? Later, we'll get into, given a function like x to the third power minus 2x plus 5. What is the end behavior? And you have to do a little bit of math with it. But with these today, it's literally just looking at the problem and knowing what it says or what it's doing. So let's talk about it. End means the ends of the graph. So for this first example right here, this is an end and that's an end. Those are the ends of the graph. And behavior means what's it going to do? What's it going to continue to do? So we know, I think, that this arrow tells us that this line is going to keep going up, right? And where? To the up forever and to the left forever, right? It's the behavior of it. We know what those symbols mean. Same with that point, that arrow. The end behavior tells us it's going to keep on going down and to the right. It just continues on and on forever. That's the end behavior, okay? And so the way we write that is two different ways. You literally, this is kind of basic, but it's how we do it, you write arrows. And we keep it in the same order as the graph. We're pointing up, we're pointing down. That's part of your homework, knowing how to put those arrows. But let's take it one step further and ignore all this stuff down here. We don't do that, so pre-count. This is what's happening as we go to the left. We rise to the left, right? As we go to the left, we're going up. And what happens as we go to the right? We fall to, and you can write the word the or not. Rise to the left, fall to the right. So if it's going up, it's a rise. If it's going down, it's a fall. And we always do left, then right. The same way we read a graph, left to right. That's the way our arrows go. That's the order we write these in. Okay? Look at this one. I wouldn't give you one like this. We wouldn't use this kind of graph until we get to pre-calculus or calculus. But what this graph is a horizontal line, and the end behavior is what we call constant, but I didn't see that we had that one in there, so don't worry about that one. I'll only give you one that actually has behavior happening. Okay, so look at this one. We are going down on the left, and we're going up on the right, right? Down on the left, up on the right. So we would say falls left, rises right. Okay? Do either of those have extrema? Nope. They're lines. No extrema. There's no points. There's no turning points. There's no curves in the road. Okay? So if you had a question like that for those problems, you'd say none. They don't have extrema. Let's look at these two. Same thing. Describe the end behavior. We can do this with nonlinear functions as well. Those were both linear lines. These are nonlinear. So this would be up, up, right? End behavior is up, up. Rises to the left. And rises right. That's right, JT. Rises right. And look, I already got lazy. I stopped writing the 2. It's fine. Rises left, rises right. So this one, on the left, it goes down. On the right, it goes up. So what will we say for the left behavior? It falls, yeah. And then rises. Okay? So it's all about what's happening on the end. Okay? And turn it over. And this is really all we're doing, except we're going to add in the relative min and max stuff, just like we did yesterday. We have a down, down, right? Falls left, falls right. I mean, how many more examples do we need? It's the same thing over and over again. It's just, can you see what the picture's doing? And do you know left from right? Pretty much, right? Down is fall, up is right, or rise. And they can give us like a word problem one. Don't let that bother you, okay? So, actually, I didn't actually even give you any of those, so don't worry about that. So this is really all you're doing. When I give you the homework assignment, I'm going to change the directions a little bit, so I want you guys to look at it. So as I told you, today's assignment is not going to take you the whole period. You should all be able to finish your homework in class. Use that time, guys, and go back and see if there's anything you didn't finish. Because on that Thursday, I'm going to be checking, let's say, 2 homeworks from the beginning of the year to where we are. So make sure they're all done and ready. So you get perfect scores on homework. There's no reason to not to when I give you so much time in class. Also, if you're one of the 3 people that hasn't taken the quiz, please take a look at the quiz review and ask me any questions on the quiz review so you guys can be ready to maybe take the quiz tomorrow in class. Okay, because we got to get those caught up. All right, so here is your homework. It's on the same page as yesterday's. So we're on, I just don't want to overwhelm you with everything I have written there. So A7, page 29 and 30. So go to the practice page. 6 through 10, 12 through 17. So please write that down. And you're going to do just the end behavior on 6 through 10. EB means end behavior, just like we just did. So follow the directions. And then 12 through 17 on the back, you're going to do the end behavior. And you can just do the arrows on this one. And then give the relative mins and maxes, or just the extrema, I should say. Okay? So that's for 12 through 17. And you're going to have to estimate some of them. They're not perfect. Okay? So here's the assignment. I'll put the key to the first part up. I don't want to confuse you guys. That was yesterday's work right there. So on the first 4, show the end behavior both ways. When you get to the second set, you can just do it the one way.